Hey guys, welcome to another lecture video for Chem 104. In today's lecture, we are going to discuss what the pH and pOH scale is, and we're also going to perform pH calculations. Now, when we're performing pH calculations, not only are we going to quantify the pH of a solution, but we're also going to determine how to calculate the pOH of the solution, as well as the concentration of the hydrogen ion and the hydroxide ion. Now, before we start, I do want to mention that H3O plus or hydronium ion is equivalent to that of a hydrogen ion. And I'm just going to go ahead and just write this off to the side. But if we have a hydrogen ion and it interacts with a water molecule, because hydrogen ions typically don't exist as H+, they typically exist as H3O plus in solution. And so sometimes we represent H3O plus as simply H+. It's less work for us to write. Okay, so let's go ahead and talk about the pH and the pOH scale. A pH scale measures how acidic or basic a solution is with respect to the amount of hydrogen ions or hydronium ions present in solution. And so the key part to this definition is that it is measuring the amount of hydrogen ions or hydronium ions present in the solution. Now, when you guys are taking a look at the pH scale, the typical range of a pH scale is 0 to 14. However, it doesn't stop. The pH scale actually does not stop at 0, nor does it stop at 14. And this is the reason why I put an arrow on the left side of this pH scale and another arrow on the right side of this pH scale. And so you can, in other words, you guys can have a pH that's like 20, or you can have a pH that's -5. And we'll understand what these pH values mean in just a second. So if you were to take a solution, an unknown solution, and if you were to stick a litmus paper, and if that litmus paper turns red, then that is informing you the pH of the solution is less than 7. And so if your pH is less than 7, you would consider that solution to be acidic. Now, if you were to take another unknown solution, and if you were to place a litmus paper, and if that litmus paper turns blue, then that's letting you know that the pH of that solution is greater than 7. And we would consider that solution to be basic. Now, if it turns out that a third unknown solution has a pH of 7.00, then we would say the pH of that solution, then we would say that solution is neutral. Okay. Now, if you look at the definition of pH scale, it is measuring how acidic or basic a solution is with respect to the amount of hydrogen ions. Now, if you guys are just looking at these numbers, 0, 7, 14, how can a pH value of 0 represent something that is acidic? So if you think about it, 0 represents an absence of value. And so how can an absence of value represent something that's acidic if that value is representing the amount of H+? And so if you had like 0 H+, how is that acidic? And so it turns out that the pH has a mathematical definition. And so the P in pH is representing the negative log of the concentration of H plus or H3O plus. Okay. And so this bracket represents molarity. And if you recall from our last chapter, molarity is a ratio of moles of solute over liters of solution. And so molarity is describing concentration. Okay. And so if a pH has a value of 0, we want to learn and understand how that informs us of the concentration of H plus in solution. And so if our pH is equal to 0, then that means that if we plug it into this formula, so I'll just go ahead and rewrite it here just to make sure that my notes are clean. So pH is equal to negative log of the concentration of H plus. If we plug in 0, where pH is found in this equation, we get 0 is equal to negative log of the concentration of H plus. And so if you wanted to calculate the concentration of H plus, you would want to get rid of the negative and the log, this word log, so that you can go ahead and isolate what I've boxed. And so to do that, I'm going to go ahead and do this stepwise. So the first thing that I'm going to do is get rid of that negative sign. And so that's going to give me, 0 divided by negative 1 is still going to be 0. And so log is a specific function, and you guys don't need to know the definition of logs, just know that it's a function inside your calculator. So if you guys look at your calculator, go ahead and look for log. Typically this function is going to be found in a scientific calculator and not a basic calculator that only has plus, minus, division sign, and multiplication sign. And so to get rid of this log, you're going to perform the antilog, which is going to be the base 10. And what you do on one side, you have to do to the other. And so that cancels out, and that's going to leave you with a concentration of H plus is equal to 10 to the power of 0. Now to access this base 10, this antilog, typically in a scientific calculator, you guys are going to type in second, and it's found somewhere on the top left corner of your calculator. And then after you type second, you're going to hit the log button. And so if you do that, your screen should pop up this function, so base 10. And so what you're going to do is you're going to press 0, and if you take 10 to the power of 0 or anything to the power of 0, that's going to give you 1. And so it turns out that the concentration of hydrogen ions is not 0 when pH is equal to 0, right? So remember that question I started off with at the very beginning. How can 0 represent something that's acidic if 0 mathematically represents an absence of substance? And so by applying the formula for pH, the concentration of hydrogen ions is not 0, rather it's 1. Or more specifically, it's 1.0 molar. And we'll talk about sig figs for pH in just a second. It's very, very specific. Okay. And so this is a concentrated solution. There's a lot of hydrogen ions that's in that solution. And so if you guys recall molarity, it's moles over liter. And so what you technically have is 1 mole of H plus ion in 1 liter. And so if you extend this concept, remember that a mole represents 6.022 times 10 to the 23 of whatever substance it's attached to. In this case, it's going to be hydrogen ion. And so in a 1 molar solution, that specific solution is going to have 6.022 times 10 to the 23 hydrogen ions per 1 liter. Okay, so that's a lot. And so what we're going to do is we're going to repeat the same process for the opposite side of this pH scale, just to understand why 14 is considered basic. And so if the pH of the solution is equal to 14, we're going to go ahead and determine the concentration of hydrogen ions by using the formula pH is equal to negative log of the concentration of H plus. And so since the pH value is equal to 14, we're going to go ahead and plug 14 where pH is in this equation. And so 14 is equal to negative log of the concentration of H plus. And once again, to solve for the concentration of H plus, we're going to divide by negative 1. So that's going to give us negative 14 is equal to log of H plus. Now to solve for this H plus, we have to get rid of this log. And so we're going to take the antilog of both sides. So remember, it's that base 10 function in your calculator. And so what you get is 10 to the negative 14 is equal to the concentration of H plus. If you were to plug this into your calculator, what you would get is 1.0 times 10 to the negative 14 molar concentration of H plus. And so if you were to expand this scientific notation, just to put these values into perspective, that would be 13 zeros before we hit the 1. And so this is going to be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we're going to hit that 1. And then finally that last 0. And this is going to be the concentration of H plus when our pH is equal to 14. Okay, and so if you guys are looking at this decimal, that's not a lot of hydrogen ion concentration compared to, for instance, a 1 molar concentration.